Alright, 5-9, last section before the chapter test, operations with complex numbers, day 1. We're going to be able to perform operations with complex numbers. So first let's take a look at this. This is a imaginary axis, real axis. Alright, so we're going to be able to graph imaginary numbers. Right, so we need to make sure that our complex number is in the form of a plus bi. So the real number first and the imaginary number second. After that, you move on the real axis the value of a, so whatever your number is, you're going to move on the real axis, so negative left, positive right. Then we move on the imaginary axis the value of bi, so whatever b is, if it's negative you move down, if it's positive you move up. Alright, so now we're going to graph each of the complex numbers. So 2 minus 3i, so you move right 2, down 3, plot your point. Negative 1 plus 4i, you move left 1, up 4. 4 plus I, you move right 4, up 1. And for negative I, you don't move left or right, you just move down 1. Alright, just like graphing regular numbers, just now we have an imaginary axis. So here's the now you try. There's a graph, imaginary graph, real axis on the guided notes for you. Okay, now we're going to use those values after graphing like that so we can see how we can calculate the absolute value of complex numbers. All it is the Pythagorean theorem. Alright, we make a triangle to find the distance of our a plus bi. We take the square root of a squared plus b squared. You do the math down till you get a value. So let's look at a couple. Find the absolute value of each value. Remember, have it in the form of a plus bi. Fill in the a value and the b value, and then just simplify. So we have 3 plus 5i. Make sure it's in the form of a plus bi. This one already is. Set up the radical. Okay, so 3 is your a, 5 is your b. Square 3 and 5, you get 9 plus 25. 9 plus 25 is the square root of 34. The square root of 34 is your answer. Doesn't simplify any. Absolute value negative 13. Set it up in the form of a plus bi. Negative 13 is your a. There is 0 for bi. Plug in negative 13 for a, 0 for b. Negative 13 squared is 169. Square root of 169 is 13. One more. Negative 7i. Alright, there's no real number, so it's 0. So a is 0. Negative 7 is our b. Set it up. 0 for a, negative 7 for b. Negative 7 squared is 49. Square root of 49 is 7. So follow those same steps for yours. Here you go. Now we're going to add and subtract. Okay, write it in the resulting form. So a plus bi, make sure the imaginary term's second. So we're going to have 4 plus 2i plus negative 6 minus 7i. Alright, if the operation is subtraction, distribute the negative to all the values in the parentheses after it. Okay, this one's positive, so we don't need to distribute. Step 2, identify the like terms. Okay, so for complex numbers, it's the real part and the imaginary part. Alright, we already dealt with matching these up in the previous section. The 4 and the negative 6 are the real parts. The 2i and the negative 7i are the imaginary parts. So we're going to combine those like terms. 4 minus 6, and then 2i minus 7i gives us negative 2 minus 5i. Okay, and it's already in the form of a plus bi. Alright, 5 minus 2i minus negative 2 minus 3i. So since it's subtraction, we have to distribute the negative through. Okay, when we do that, negative times negative 2 is positive 2, negative times negative 3i is positive 3i. Identify the like terms, so the real terms and the imaginary. So the 5 and the 2 are the real part, The negative 2i and the 3 are the imaginary part. Combine your like terms. 5 plus 2 plus negative 2i plus 3i gives us 7 plus I. It's already in the form of a plus bi. Now your turn. Alright, take notice the first one's subtraction. Make sure you're doing the right steps. Now, multiplying. So multiplying is with complex numbers is just like we do multiplication with regular numbers. You just have to be able to work with the I term. Okay, so multiply based on the situation. This situation just calls for the distribution. Okay, so we're going to distribute the negative 2i to the 2 and to the minus 4i. In doing that, negative 2i times 2 is negative 4i, and negative 2i times negative 4i is positive 8i squared. Now we're just going to simplify that. In doing that, remember, I squared is the same as negative 1. Anytime you have I squared, you can replace it with negative 1. Okay? So now you have negative 4i plus 8 times negative 1 becomes negative 4i minus 8. Finish it out by writing in the form of a plus bi. Alright, so your imaginary term is second, so it's going to be minus 8 minus 4i. Let's look at another situation. Alright, so we have the quantity 3 plus 6i times the quantity 4 minus I. Alright, we're going to multiply based on this situation. This one calls for FOILing. First, outers, inners, last. So the first terms, 3 times 4 is 12. The outer terms, 3 times negative I is negative 3i. The inners, 6i times 4 is 24i. And the last, 6i times negative I is negative 6i squared. From there, we're going to simplify. We're going to combine all like terms, replace our I squared with negative 1. Okay, negative 3i plus 24i is 21i. Since the I squared is negative 1, and we take negative 6 times negative 1 is positive 6. I can now combine my 12 and my 6. That gives me 18. So I have 21i plus 18. Last step, we're in the form of a plus bi. So it's going to be the 18 first plus 21i. Alright, last one for our example for multiplying. Alright, multiply based on the situation. This one here we're just straight multiplying. Okay, so negative 5 times 6 is negative 30. I times I is I squared. Simplify this. We know that I squared is the same as negative 1. Negative 30 times negative 1 is 30. Rewrite it in the form of a plus bi, which just so happens to also be 30. Alright, these are your last two for the Now You Try. Enter them in online. See you tomorrow.